Good afternoon and welcome to our 20th annual exhibit of hydrogen and fuel cells. We've added batteries this year, so we're expanding our interests. We've been talking about this fuel cell technology for a long time. One of the secrets of this industry, of course, is that it wouldn't survive without bigger companies coming with their expertise from other fields and getting involved in this. One of the examples is an automobile components manufacturer, specialists in materials. They all get involved and they help us immensely because they have a pool of expertise without which this small community of hydrogen fuel cell manufacturers just couldn't survive. One of the specialists in this field is Dr. Raimund Stroebel. He's Director of European Fuel Cell Components at Dana Holding Corporation. Please welcome with me Dr. Raimund Stroebel.
Hello. Good evening.
Hello. So, good afternoon. It seems to me that we've been hanging around here once a year for, 10 years?
This is our 11th participation at this show.
So we can look back over a long history. Perhaps, though, we could start briefly with the history of Dana as a company and how you got involved in the fuel cell industry years ago.
Yeah, Dana started to work for the automotive industry, or was actually founded to work in the automotive component industry in 1903 to provide and to supply one of the initial Ford vehicles. And based on that, Dana was growing as the automotive industry grew all over the world, providing the components where the market was, in particular automotive side. So, and a similar way, we got approached by the automotive industry as well in the late 90s of the last century, looking into the fuel cell development. And there we started to bring our know-how to this market, identified different components we thought that might fall under our expertise. And so by that, we are now in this sort of business since 16 years.
Okay, so that's a considerable length of involvement here. You know, in the past 10 years, we've seen things talked up. We've seen potential developments. Some of them have not actually turned out to be as optimistic as others. Do you remember any high points, any false promises, or any expectations that we didn't have that we now have in the fuel cell industry?
I think one of the main topics always is cost. And I think as fuel cell is a high scientific product where we have to solve a lot of material issues, durability issues. And at the beginning, it was kind of very hard time for everyone who was involved to solve these problems and really to get the cost down, get the fuel cell product out of the scientific environment, get it into companies that took care for more engineering related design for manufacturing approaches and to get sort of a market readiness for the products. Another critical aspect is always where do you get the fuel for it? So different fuel cell systems require different fuels, and so a big challenge for the infrastructure.
Okay, cost, and of course the fuel cell infrastructure has always been one of those problems. You've been involved for a long time now. We have a burgeoning clean energy market, basically. We have all sorts of pressures that focus interest on, cleaner cars and so on. And there you've been involved also for a long time. What is the recent development that you've seen?
Well, first of all, for a company like Dana, it's always important to provide new products to the market, to sustain as a company itself with new products. Other products will be replaced. And due to that, we are trying to grow into the market where we see a strong pull. And one of the main factors is efficiency, as well as more cleaner, high efficient vehicles with a lower CO2 footprint. And this is where we see the future is going, based on regulations, and that's why we are investing in this technology.
You've bought two wonderful objects which we can address directly here. One of them is already a success story.
Yeah.
You're involved in a really innovative,
Yeah,
large-scale manufacturing product there. Can you talk a
Yeah.
bit about that?
Yes, I brought sort of two quite similar products. One is actually a intercell cooling element for the GM Volt, what we supply, 144 units per vehicle. Based on the couple 10,000 units that are sold, this is already a significant volume. And this is a very nice story. 6, 7 years ago, nobody was talking about battery vehicles too much. Nowadays, battery hybrids or full electric vehicles are on the road. They're out for sale, and this is a technology what we see already materialized, and very similar to that is the metallic bipolar plate what we have developed. Both are two very thin metal sheets joined together. They do have different requirements. We're talking about aluminum or stainless steel, but the volume scale is quite similar, and that's what we're expecting for the future, that we also will see ramp-ups on the metallic bipolar plate similar to the Volt plate, and this is the main reason why we got involved in this.
Dana really brings two huge advantages to the fuel cell industry. One, of course, is the material expertise, and the other side is you can ramp up any production. You do large-scale production. This is something that is rare in the fuel cell industry. So for me, it's interesting to know, as you get involved, do you cooperate through the phases of development? Do you talk to the fuel cell manufacturers and the automobile manufacturers who are trying to create hybrids and help them to develop a product? Or do you get involved when the design is done?
No, we tried to get very early involved with selected companies. We tried to work with the market leader in this area. We cannot work with everybody due to the different, let's say, the number of companies that are working in this industry. But we're trying to pick out the right customers to develop our product with them, and then to go with them into the market and spread our technology in the market. Because we need to be involved in a very early stage to work with them to bring our expertise on materials and manufacturing to get the right designs into place.
Okay. For me, it's interesting when you look at the energy storage issue, which seems to be a huge issue. It is a huge issue in Germany. It's also an issue wherever there is renewable energy, because the cycle of supply does not coincide with the cycle of demand. Now, why do I mention this with an automobile manufacturer? Well, simply because if you have a lot of electric cars that charge up whenever there's an excess of electrical energy, and if you have an electric car hooked up to your house and you have a peak demand, you can actually use the battery of your car to aid the grid in dealing with peak demand. Okay, so this is one case where the obvious help that the cars could perform to the electrical energy grid, it's already an established fact. So, but the second question is, where's the car? So this is why I have to ask the question, what were the obstacles in developing a battery-powered car? Why did it take us this long to get there? Was it simply because gas was too cheap, or that the energy issues were not in focus, or were there real problems of, let's say, how far can you drive a battery-powered car?
Well, I think that's the last one is one of the main issues, that we do have only a limited driving range for a certain amount of cost and weight in the vehicle, and because of that, that's what kept everyone from investing into this, because the ideal concept, everyone wants to drive as much as possible with one refilling, and also the costs, to get down the costs is still one of the main issues. And as you can see from the cars that are available today, full electric vehicles or plug-ins, the additional costs on these vehicles are extremely significant, and so the market will be for still some time quite narrow and lower than we would like to see.
Okay, so we all know if you've been to California, there's certain specific lanes. My brother lives in Silicon Valley, and there's people stuck in those lanes that just do not move because only the hybrids or the people with 4 people in the car are allowed to use those special lanes, which are never blocked up. So it really is an interesting political decision on the one hand, but the other hand, it is a huge service to the entire industry. Once we get those cars rolling, though, is their range satisfactory? You know, many people overestimate, depending on what we expect from a car, the amount of miles one filling needs to take you. Do we really need to always have 800 kilometers worth of diesel fuel in our car? If you're a commuter, for instance. So is this a mentality question? Do people redefine the way they need or use a car when they adapt to using an electric car? Do you have a view from the user's side of what's happening there?
It's more a psychological question than a practical question, I guess.
Okay.
Yeah.
It's Ask Dr. Freud. But what does Dr. Freud say about this? People have the psychological notion, which is untrue, that you need to drive 800 kilometers on a tank. Do you have a feeling for that?
No.
Okay. There are certain issues, though, that people talk about this issue with hydrogen automotive applications. And that's another issue which is fascinating because you're involved in the bipolar plates. It's an issue because if you want to have vehicles that serve a function and are right now viable, you're looking at indoor applications of forklift trucks, hybrids with batteries and hydrogen fuel cells. And there, the viability is largely proven, but still you have all those issues of how do we reduce the costs of the stacks.
Yeah.
On that note, this is an automotive application bipolar plate. What's new about it? What is specific about the Dana's approach to that?
Well, this particular one is not an automotive application.
Okay.
This is sort of a demonstrator vehicle. The size is too small. But nevertheless, it has all the functions that are required for an automotive application. And we in Dana, we have developed over the last 15 years technology to cover the material issues for the base material itself. We developed coatings and also the design to integrate the seal into the plate to come up with a complete system to provide it to our customer as a full controlled unit. And so they can assemble easily their stacks with a solution out of one hand. And that's our main technological advantage on this product.
Okay, so on the assembly side, that potentially reduces the amount of work that goes into putting things together.
Yes. Yeah.
And on the manufacturing side, there's always the issue of how many engineers at the table do you need with scissors to create this, or is this a mass manufacturing process where you basically stamp things together? And
this is a mass manufacturing product, where everything is fully integrated in the production process, and we can run it with a very high speed for the individual components.
Okay. How's the market right now?
Well, we see, let's say, on the development side, a very big demand for our products. We don't have real signed contracts for start of production yet, so we're not quite sure when this is going to happen. But based on what we heard earlier today on the infrastructure strategy globally, we see a quite good sign for fuel cell powertrains in the near future. And hopefully this century.
Hopefully this century. We're only at the beginning. If there are any questions, by the way, from the audience, just raise your hand and we'll bring you a microphone.
I'm really glad to hear the perspective from the component manufacturer side today. You know, there's a value chain of fuel cell, which is a relatively young market for commercialization. And there are multiple companies in the value chain, and some of the companies are doing most of the value chain too. Do you see any trend in the value chain? For example, some companies vertically integrating, or some companies like specializing in certain value chain?
I think this is not really fully decided yet because the business plan is still quite unclear. So it's not really clear from our perspective how the integration will work. And it's also depending on the different components.
Are there any other questions from the audience?
Thank you very much. My question is about the material. For example, this is stainless steel. What is the cost-related difference between stainless steel and graphite bipolar plates?
That's quite volume dependent. So it's depending on which volume you're talking about, and then the volume and size dependent. That might be an offline discussion.
Okay, maybe it's around 10,000 bipolar plates.
Yeah, we may have to discuss that offline.
There's still, of course, a lot of insider knowledge, I suppose, in the industry would be a way to put it. But we were talking about this during the warm-up for this discussion. There are various ways of approaching the automotive applications. I was quizzing you about this. Do you work on durability? I remember conversations where everyone was saying, well, you know, the cell stack has to operate for 20,000 hours at least.
Yeah.
Because they were so damn expensive. If you reduce the cost, you can talk about replacing stacks with a bit more ease, but they were incredibly expensive if I go back to like 10 or more years. So there's a bit of wiggle room, as I understand it, between do you go for maximum durability, high-speed manufacturing, which is also a cost saving. You have a unit here which you just, as you explained, it allows you to assemble it with more ease. But do you see any trends there? Is durability, is this true? Do you really need 20,000 hours of operating time, or can you reduce the cost of a stack so that maybe replacing the stack is a...
Well, durability is always application related. So in the typically what the automotive industry is requesting something like the 6,000 hour durability on a full cycle, drive cycle conditions. If you look at more stationary applications, 20,000 hours is almost nothing. So there, let's say the community would like to see something like 40 or 80,000 hours. On industrial mobility or uninterruptible power, power supply, we see much lower durability requests and smoother drive cycles. So there, I think the durability issues are quite good solved, and that's why this market niche is progressing quite solid. So.
Okay. And I imagine for the backup power sources, they're also not looking at backup power for 20,000 hours potentially. It could have a shorter lifespan and still fill the job.
Yes.
Okay. Abstracting from all of these concrete questions, we started this conversation with an overview. You've been here for 11 years in the Hanover Messe. What do you see coming up next? Where do you see developments? Where is your curiosity piqued the most in the fuel cell industry?
Yeah, we would like to see, or our most interest at the moment is how does the infrastructure develop? Because if that sort of develops by, let's say, governmental support or regulation, then we will see also a market pull for this industry. Yeah.
Okay, so we have to get on the backs of those infrastructure specialists, but that is one of the discussions we've been having today, so there's hope for us all.
Yeah.
Well, I've been talking to Dr. Raimund Stroebel, who's Director of European Fuel Cell Products at Dana Holding Corporation. It's been a pleasure. We've been here before on the stage together. I hope I see you next year and in the years to come.
Yeah, thank you.
Okay, thank you very much, Raimund.